Very well. So what we learned before in elementary calculus, we talked about the derivatives, then we talked about the antiderivative, which is the opposite operation of taking the derivative. So just to recall for you, for any function like y equals to f of x, if you're able to define the limit definition of the derivative, then we can use those shortcuts and take the derivative of the function. We can take the derivative. Well, derivative is an operator. In linear algebra, you're going to see what an operator is and how to apply an operator for different objects that we later on, you see, we're going to work with matrices. So the derivative is an operator. Now, how did we define this operator? It is d over dx. If the function has free variable x, then we're going to take in the derivative with respect to x, and this guy is called an operator. So this operator on function f of x is denoted by d of f divided by d of x, or simply f prime of x. So like defining addition and then subtraction, multiplication, division, they're opposite operations. We can define the opposite operator for derivative, which is antiderivative, or eventually remember that we call it the integral. The opposite operator of the derivative is antiderivative. Okay, antiderivative. Well, remember that to define antiderivative, we take the Riemann summation, then n goes to infinity, and we change that, the sigma, capital sigma, into long S, and we call it the integral of function f. Okay, if we have a function f and we are taking the integral of function f in different branch of science, the integral has a different meaning. Well, sometimes when we are working with integral, one of the simplest example is the area below the curve. Just one instance. Guys, remember that in different branches of science, integral has a different meaning. In physics, you might say, hey, we are looking for the work done, or in electricity, it has a different meaning about the charge. In statistics, it has another meaning. Sometimes the meaning is the area. So we say that, hey, they have x-axis, they have, for example, y-axis, and suppose this function is a positive function. What's the meaning of that? It means that this function is above x-axis. Suppose this is your function f of x. And then you say that, well, I can evaluate the area below the curve. And suppose my x is bounded between two numbers, like a and b. So I have a definite integral, definite area. The area below the graph of f, when x is bounded between a and b, is the integral of function. Again, this is just one of the instances of integral, the area. In other branches, we have different applications for the integral. They have different names. for the integral, it's not exactly the area. Very well. So now you're saying that, well, this is defined for a function with only one free variable. Now, suppose I have a function with two free variables. How do I define the antiderivative of that function over the given area? There, we're going to talk about the double integral, and eventually we're going to generalize the idea to triple integrals. Very well. So now that we are in multivariable calculus, we have functions in more than one free variable. We're interested in finding the integral or antiderivative of those functions. So now, how to find the integral of function like z equals to f of x and y? This is the question that we're trying to answer. To answer this question, we need to specify the region over which we're trying to take the integral. So you can write down depends on the region. What do I mean by that? We can divide up the region that we are taking the integral over into two specific forms. The first one is just called a rectangular region. So, rectangular region. If you have a rectangular region, what's the meaning of that? It means that that region is defined as A, B on x-axis times C, D on y-axis. Well, so your x ranges between A and B, and your y value ranges between C and D. These are just numbers. Y range. So how do we visualize that? The visualization is like this. Here you have your x-axis, then you have your y-axis, and then you have your surface, whatever it is, on top or below, z-axis. So this region is going to be part of the domain in xy plane. So we're going to have A to B, then C to D. Well, okay, my y ranges between C to D. So the intersection between these two is going to be this region down here. Okay, here we go. This continues, and this is this region. So this guy is the interval A to B cross C to D. This is the region that you're dealing with. So where is the function? The function can be just right here. This is your surface. Z equals to f of x and y. What are we trying to do? We're trying to find, in physics language, we are trying to find the volume bounded between this function and this area. So this is C and D. We are trying to find the volume between this function and this region down here. It's not exactly straight line because here you have a surface and the behavior of the surface might be different. So we are trying to find this guy here. This volume, you have some heights. You take each of these heights in a very small, nice infinitesimal, and then multiply each height by its base, add them all together, and define the double integral. So to find the double integral, it means that we are trying to find, in physics sense, the volume of this region, this part, which is bounded between the surface and this little rectangular area here, the volume of the portion bounded between the surface, z equals to f of x and y. So here you have your heights. These are the heights. You have the base, multiply them together, and since this is not a flat surface, we don't have the exact measurement, so that's why we have to use the integral. So surface z and the base a comma b times c comma d. Again, this is not a flat surface. It is changing. Based on the value of z, you get different heights. Since z equals to f of x and y is changing, we have to use the integral. So very well, we're going to take double integral. Why is that? Because we have two variables, variable related to x and variable related to y. Okay. So this is the limit. If you want to just use one variable, it's going to be limit of Riemann sum f of x delta x. Riemann sum and your x is changing, but here we have two variables. It's not just one variable. It means that we have to use two Riemann sums. One related to x, one related to y. Here the order is not important for us. Delta x and delta y, and here you have your function f of x and y. As these small regions, these small delta x times delta y's are getting smaller and smaller. So this is delta x times delta y. These base values are getting very small. You are just taking the limit as these values are getting smaller and smaller. Remember the definition of delta x? It was b minus a divided by n. These are getting smaller and smaller as n approaches infinity. The same definition for delta y. This Riemann sum, as n approaches to infinity, it's now defined as the double integral. The double integral of the function, and delta x becomes dx, delta y becomes dy. Well, delta x is related to x, the change in x values. Well, x is bounded between a and b. So A. This is your inner integral, which has to be calculated first. Inner integral. Then the outer integral is related to your y. The outer integral related to y. So y ranges between c and d. So your lower limit is c and your upper limit is this guy. This formula gives us the volume of this portion of the surface bounded between these little region in xy plane. So here's one example for you when you have a rectangular region. When you have a rectangular region, taking the integral is not very hard. We just need to remember our elementary calculus integrals and just start taking the integral. So let's see. Examples. I'm going to write down one example here for you. This example says, find the double integral of function z equals to x minus 3y squared, over the following region. The region R is defined as, well, you have a set of points such that x is bounded between 0 and 2, x is bounded between 0 and 2, and y is bounded between 1 and 2. Okay. The boundaries for x and y are both fixed numbers. It doesn't matter if you take the integral with respect to x first or with respect to y. Both of them gives you the exact same number. So this is my C and D. I'm going to use different colors. This is my A and B, then these are my C and D. A and B, and this guy is C and D. The double integral, remember that, the double integral of function f of x and y over a rectangular region is defined as dx dy. It means that you can take the inner integral with respect to x. So this is my inner integral. Inner integral first integral. Inner integral, x is ranging between a and b, 0 and 2. Then you take the integral with respect to y, okay? Outer integral. dy, y is ranging between 1 and 2. 1 and 2. Very well. It's not very hard. You have the function here. This guy is equal to the double integral x minus 3y squared dx dy. My x ranges between 0 to 2. Again, this is your inner integral. You have to calculate this integral first. Then you move on to calculate the integral with respect to y, 1 to 2, the second integral. Okay, recall that. The integral of x minus 3y squared dx. Well, here you have x. The integral of x dx is equal to x squared divided by 2. Integral of negative 3y squared dx. Guys, we are taking the integral with respect to x. It means that whatever term has a y in it considers as a constant, a number. So this guy is nothing but a constant. It doesn't have any x in it. It's just a number. So which is equal to copy down the number, negative 3y squared, multiply that by x. So this integral is equal to x squared divided by 2 minus 3y squared x. And since it's a definite integral, we plug in 2, we plug in 0, do the subtraction. Well, if I plug in 2, what do I get? I get 4 over 2 minus 3y squared times 2. If I plug in 0, both of these terms are equal to 0, so I'm not worried about this. So I get 2 minus 6y squared. Where does it go? This is the calculation of the inner integral. So this integral is equal to, I copy down my outer integral with respect to y, 1 to 2, and my inner integral is now 2 minus 6y squared. dy. Now we start taking the integral with respect to y. Very well. The integral 1 to 2, 2 minus 6y squared dy. Well, the integral of a constant to dy is 2y. The integral of negative 6y squared dy, you copy down your negative 6, y to the third divided by 3, which is negative 2y to the third. So this integral becomes 2y minus 2y cubed as your y changes between 1 to 2. If I plug in 2, what do I get? I get 4 minus 2 times 8 minus, if I plug in 1, I get 2 minus 2, which is just 0. So the outcome is 4 minus 16, which is negative 12. This is my integral. Negative 12. Guys, note that I didn't ask for volume. I just asked to calculate the double integral. We don't have negative volume. This guy doesn't refer to a volume. It refers to something else. We just did the work in pure math sense. There you go. So remember that I mentioned it doesn't matter if you take the integral with respect to x first, then take the integral with respect to y. So I expect you to ask, what if I take the integral with respect to y first? Let's take a look at this. Let us investigate, see if we get negative 12 at the end or not. So now I claim that I'm going to take the integral with respect to y first, then with respect to x, and I get the exact same answer, negative 12. Well, double integral. Now my inner integral is with respect to y, outer integral is with respect to x. I'm going to copy down my function, x minus 3y squared. Take the inner integral with respect to y. Take the outer integral with respect to x. Well, what do I see? This is my inner integral. I have to calculate this guy first, and my y ranges between 1 to 2. After I done with the inner integral, I move on to calculate the outer integral, this time with respect to x, well, 0 to 2. Outer integral. So let's see. So let us find the inner integral first. Inner integral. My inner integral is integral with respect to y, while y is between 1 and 2. And my function is x minus 3y squared dy. With respect to y, x is just a constant. It means that you have to copy this guy down. This is equal to the integral. Let's just write down the final answer. X times y minus, here you have 3y squared. You get 3y cubed divided by 3, and your y ranges between 1 to 2. So you can cancel out 3 and 3. Your y is 2, your y is 1. So you plug in 2 first. 2x minus 2 to the third minus, if you plug in 1, you get x minus 1. So here you get 2x minus 8 minus x plus 1, or x minus 7. This is your inner integral. Goes here. So far we have the integral x ranges between 0 to 2 of x minus 7 dx. This is your outer integral. Let us calculate the outer integral. Our outer integral with respect to x, it is 0 to 2, x minus 7 dx. Well, this is easy. The integral of x is x squared divided by 2 minus the integral of 7, 7x, and x is between 0 to 2. If I plug in 2, I get 4 divided by 2 minus 2 times 7, 14, minus. When I plug in 0, I get 0 minus 0, or just 0. So what I have 2 minus 14, which is again negative 12. So this double integral is minus 12. It doesn't matter if you take the integral with respect to x, with respect to y, with respect to y, with respect to x. You get the exact same answer. Why is that? Because we have the constant boundaries for x and y. So if we have rectangular regions, it means that they're super lucky. Everything is easy about rectangular regions. You don't have to worry about anything. You saw that you can take the integral with respect to x, with respect to y, and it gives you the exact same value. Again, remember that it's not always finding the value. Some other times we are finding, for example, different types of quantities related to the topic that is given to us. In math, our main goal is to present different techniques to solve different problems. We're not really worried about what the application is. We just mainly want to try to come up with best technique that help us to solve that problem. Okay, perfect. So for rectangular region, you learn that, hey, we can take the integral with respect to x. For x, I'm going to use a different color so you don't get confused about these. So dx, x, and then dy, y. Remember, you always have to take the integral, inner integral first. Inner integral comes first. First this guy. Then the second step is to find the outer integral. This is the second. This guy is equal to, no matter the order of integration, this is always equal to taking the double integral with respect to y, then with respect to x. It doesn't matter at all. You must get the exact same value. Now your inner integral is with respect to y. This is coming first. And then you take the integral with respect to x, which is going to be here. Here we go. And all of these are related to elementary calculus techniques integration. So this is the second. Now I expect you to ask, what if, as Grace asked, what if we don't have fixed boundaries? What if my A is bounded between two numbers, but my Y is different? So when it comes to non-rectangular regions, we have two cases. Case one is the case that your x is bounded between A and B. Your x is fixed, A and B. But your y is bounded between two functions. Y is bounded between two functions that are functions of x. So here we have, for example, g of x and h of x. Then the setup is like this. Your double integral must have x outside. X must be outside. So your x, A to B, and your y is inside. So this is f of x and y, dy. You cannot change the order. Gx, hx, and x. This guy comes first, taking the integral with respect to y. It is your first integral. And then you take the integral with respect to x. Because your x has numbers, you can plug those in and get the final answer. Second. But if your y is fixed, your y goes outside. Second case. Your y is bounded between C and B. And your x is bounded between two functions related to y. X is bounded between two functions. What are those two functions? Let us call them gy and h of y. Then your y must be outside. Your outer integral is with respect to y because it has fixed boundaries. And then inner integral is with respect to x. You write down your function, dx, dy. You take the inner integral first with respect to x. And the boundaries for x, gy, hy. And then you take the integral with respect to y with boundaries c to d. So this is your second integral to evaluate. Very good. Give us an example. What are you talking about? Well, so we don't need rectangular regions anymore. And so here we go. Suppose we want to find this integral. Example. To find example. What is this guy talking about? It says, let R be the region. Let R be the region bounded by, okay, bounded by y equals to x squared and another function y equals to square root of x, and calculate the double integral of x squared times y dA. dA, it means that it doesn't mention you are taking the integral with respect to x or with respect to y. This is the area element over region R. So let me erase this part of the board. I need more space. So note that dA can interpret it as dx times dy, or dA can interpret it as dy dx. We need to decide on that. Well, so what is our very first step? Your very first step is to graph this guy. Step one. Graph the region. Okay, it's not that hard. I know this is a quadratic function and this is a radical function. I already know how to graph these two. Well, okay, this is my x, this is my y. And let's use this guy here. This is my x squared. And this guy is my square root function. So what's the region? The region bounded between these two functions. Bounded between these two functions, okay. This is the region R. This is region. Well, I only have these two functions. Remember that. I need my x bounded between some things. But what? Step two, find the boundaries for your x. You already know your y is bounded below by x squared and on top by square root of x. Step two, find the boundaries for x. But how? Simple algebra. I set these two functions equal to each other and solve for x. Set x squared equals to square root of x. Raise both sides to the second power. You get x to the fourth equals to x. Bring x to the other side. X to the fourth minus x equal to 0. If you factor out x, you get x cubed minus 1 equal to 0. So x is 0 and x is 1. X is bounded between 0 and 1. Okay, I'm happy. I found the boundaries for my x. So now I know my x is bounded between 0 and 1, and my y is bounded between from below the smallest value that my y takes is on x squared. The maximum value that my x takes on is on square root of x. This is your lower function, and this is your upper function. Okay, so since x is bounded between 0 and 1, I decide to take the inner integral with respect to y and outer integral with respect to x. You have the double integral, x 0 to 1, and y. Again, guys, your minimum values are on y equals to x squared. So the lower limit is x squared. Your maximum values are on square root of x. So the upper bound is square root of x. What is the function? X squared times y dy dx. First, take the integral with respect to y. This is your first integral. Then take the integral with respect to x. This is your second integral. Okay, one by one. The integral x squared to square root of x squared y dy. We are taking the integral with respect to y. X squared is just a number. This is equal to x squared, y squared divided by 2. Y ranges between x squared to square root of x. So we plug square root of x, we plug x squared, we do the subtraction. This is equal to x squared times square root of x to the second divided by 2 minus x squared to the second divided by 2. So this guy, let me just write this up here to avoid any confusion. This is x squared times x over 2 minus x to the 4th divided by 2. This is my inner integral, my first integral. This is my first integral. Now I plug that in and start taking the integral with respect to x. So this is equal to the integral 0 to 1. The first integral has terms x in it. I get x cubed divided by 2 minus x to the 6th divided by 2 dx. The rest is easy. You've seen this integral before. This is x to the 4th divided by 8 minus x to the 7 over 14. X ranges between 0 to 1. So if I plug in 1, I get 1 over 8 minus 1 over 14. Here I can factor out a half. And then I can take the common denominator. Three divided by 56. I hope the calculation is correct. Let's see. Okay, let me see. Did I make any mistakes? Double check the whole thing. So here we have y. Did we do the multiplication? And this is x divided by 2, x squared, okay. Divided by 2, and then x cubed. And here I have x squared times y. Okay, I think seems okay. Well, give us another example. Let's go over another example, see what do we have. To leave these steps, we're going to follow these steps. If one of them is not given to us, we need to follow the steps. Now, so example. This example says, well, evaluate what? Evaluate the double integral of x plus 2y dA over region R, where R is a region bounded between these two functions. Y is equal to 2x squared and y is equal to 1 plus x squared. So step one.
Sorry to ask, but I was wondering, could you do one where it's the other way around?
So let's graph the region. So the region, x-axis, well, y-axis, it's not very hard to graph this because both of them are quadratic functions. So 2x squared and 1 plus x squared. So here we've got 2x squared, let's see. This is 2x squared, for example, and the second one is 1 plus x squared. So suppose this guy is like this. 1 plus x squared. And this is 2x squared. So as you can see, your lower function, the minimum values are on 2x squared, and the maximum values are on 1 plus x squared. So in step 2, we need to identify x boundaries. Step 2. Find x bounds. To find x bounds, going back to algebra, set these two equal to each other. 2x squared is equal to 1 plus x squared. So 2x squared minus x squared is 1. So x squared is 1, x is 1, x is negative. These are the boundaries for your x. X ranges between -1 to 1. Well, let's set this up. Since x is bounded between 1 and -1, it means that x goes outside the integral. So we have the integral -1 to 1, the integral of, with respect to y, the lower function, the lower bound is 2x squared, the upper function is 1 plus x squared. And here you have x plus 2y as the height. And then dy dx. This is your y and this is your x. So the inner integral, this is your first integral to calculate. This is your first. And then you move on to calculate the outer integral or second integral. Very well. So what do we have? We have the outside integral, -1 to 1. Let us directly calculate this integral with respect to y. With respect to y, you get xy plus y squared divided by 2 times 2, and your y ranges between 2x squared and x squared plus 1. Then you take the outer integral. So this y is equal to, here, if I plug in x squared plus 1, I get x times x squared plus 1 plus, I can cancel out these two, x squared plus 1 to the second power. Now I plug 2x squared in, I get x to x squared plus 2x squared to the second power. Let me close out the parentheses. Then I need to find the integral with respect to x. Well, here I can simplify whatever I have here, then take the integral with respect to x. So this is -1 to 1, x cubed plus x, plus here you get x to the 4th, 2x squared plus 1, minus 2x cubed, minus 4x to the 4th. Now dx. This is not very hard. We can simplify this guy. I get -3 x to the 4th. What else do we have? -x cubed. Well, here we have, so I have a half x squared and plus 2x cubed divided by 3 plus x minus x to the 4th divided by 4 minus 3x to the 5th divided by 5, and my x ranges between -1 to 1. After plugging the values, you get 32 over 50. So how to understand this? This is the region that you are taking the integral over. This is your x-axis, y-axis, and your surface, whatever it is, which is a plane x plus 2y, it's just up here. Suppose this is your plane. And this is your region. Okay, where we go. This is the region that you have. This is your region. Just make this a little bit more smiley. Well, okay. If you want to take a look at the exact same thing up here, you are trying to find this guy here. Let's take a look at this. This is the height, and this is your base, and you are trying to find the volume. This volume is equal to 32 over 50. So as you can see, your region is not in the rectangular form. It changes everything. It changes your volume. How do you take the volume? So our inner integral is based on the change in y values, and our outer integral is based on the change in x values. Well, so I expect you to ask, what if I don't want to take the integral with respect to y, then with respect to x? What if I just want to take the integral with respect to x, then with respect to y? Okay, let's see. Let's see what's happening here. I'm going to switch the order. I'm going to change these. Well, see which one is easier to calculate. So what does this guy tells me? This guy tells me that, well, here I have x squared equals to y over 2. And this guy says, hey, x squared is equal to y minus 1. Then this tells me that x is equal to square root of y over 2. And of course, it has plus minus. And this guy tells me, hey, x is equal to plus minus square root of y minus 1. Okay. So remember the graph. What was the graph like? The graph was like this. This is y equals to x squared, or x is equal to, well, plus minus square root of y divided by square root of 2. So here I get x equals to negative square root of y over 2. And here I get x equals to positive y divided by square root of 2. And the second function, this guy is like this. Y equals to x squared plus 1. So this is your function here. There we go. So on this part, I have negative square root of y minus 1. And on this part, I have positive square root of y minus 1. Well, okay. This makes it more complicated. Why is that? Because remember that your job, your goal is to make the integral much more simpler, finding boundaries for your x, finding boundaries for your y. Here, you need to find fixed boundaries for your y. Y is bounded between what numbers? So if you set these two equal to each other and solve for y, you get this. Square root of y over 2 equals to square root of y minus 1. So y over 2 is equal to y minus 1, or y is equal to 2y minus 2, or y is equal to 2. Okay. So it seems like my y is ranging between 0 and 2. So this is not going to be 2, but if I plug in 2 here, my y is going to be, let's see, to be a little bit off. So let's see. At this point, we're trying to find the intersection between x and y. If y is equal to 2, then my x is plus minus 1. So does it satisfy this? Yes. Negative 1 and 1. If your y is equal to 2 here, then you get x squared equals to plus minus 1. So you found the boundary for your y. Y is changing between 0 and 2. 0 and 2. Now, you need to decide about your x. X is bounded between which functions? You have 4 functions to work with. And remember that you are moving from left to right. So the minimum value, is it this guy or is it this guy? The maximum value, is it this function or is it this function? You have 4 different functions to work with. What's the meaning of that? It means that it makes it much more complicated to work with y first to identify your x, then work with y first. So if you want to calculate it this way, it makes it much more complicated. That's why when you get stuck to problems like this, try to switch the boundaries as we did before. It's better to write it this way, to calculate it with respect to x and with respect to y, as we solved it before.